Hello everyone, my name is Manu Parimi and I'm an applications engineer at PLECS. Welcome to this tutorial video on exploring the PLECS thermal import wizard. This feature facilitates the import of datasheet graph information for thermal descriptions. This is useful when a PLECS model of a semiconductor device is not available from the device manufacturer. First, from a new PLECS model, open a new thermal description. Here, you define switching and conduction losses of the device. There are two ways to enter the loss information. The first way is to enter all the data manually, either into these tables here, using a formula-based approach, or both. The second way is to import the data using the thermal import wizard. This wizard can capture curves for turn-on losses, turn-off losses, conduction losses, thermal impedance, as well as for custom tables. The Help button provides a thorough explanation of this tool. Here, I have a datasheet of a silicon carbide MOSFET from Cree. Let's use this as an example. Note that you first need to take screenshots of the appropriate graphs and save them in a bitmap file format. For example, here is a graph displaying switch on and switch off losses for a device voltage of 600 volts and device temperature of 25 degrees Celsius. I'm going to take a screenshot of the graph. Then, to enter the turn-on losses, open the import wizard by clicking on the magic wand icon. Then, drag and drop the screenshot to the thermal description window. After importing a graph into the wizard, notice that a configuration window pops up automatically. To reopen this window manually, click on the Configure Access button. Set the appropriate energy scale and enter the minimum and maximum limits of the X and Y axis. Then, align the green axis with the axis and their endpoints on the plot. It is a good idea to use the zooming option to align the axis more accurately by holding down the Control key if you're using Windows or Command key if you're using Mac OS and scrolling up the mouse wheel. You can also zoom in and out using these zoom icons in the top right. Next, I'm going to define a few data points for the turn-on switching losses, which is the curve called E on in the plot at 25 degrees Celsius and 600 volts. You can change the voltage and temperature values of the lookup table by double-clicking on the existing values. New values can be added by right-clicking on the table. Now, we are ready to start clicking away on the curve, and PLECS will take care of calculating the values by linear interpolation based on the limits you've entered. If snapping is enabled, the X value is adjusted to the nearest snap value. You can temporarily disable it by pressing and holding down the Shift key while you click on a point. However, snapping is useful for when you have data for multiple voltage values that you want to enter and therefore can consistently use the same current column values. To move points, drag them with the left mouse button. You can remove points by right-clicking the point and selecting Delete. Now the lookup table is complete. Optionally, you can rename the imported image by clicking on the Rename Import pencil icon. You can import as many number of graphs as needed. When you import a new image to obtain new data points, you can choose to hide the existing data by unchecking the checkbox. Here, I have imported the data points for turn-on and turn-off losses for device voltages of 400 volts and 600 volts for 25 degrees Celsius. Since the thermal editor uses linear interpolation and extrapolation to find the exact loss value, it's important to include a loss vector at 0 volts as well. Clicking on the magic wand icon again would close the import wizard. Next, let's look at importing the conduction losses. The datasheet has provided a curve for output characteristics for for temperatures of -55, 25, and 150 degrees Celsius. After taking the screenshot, click on the magic wand icon in the Conduction Loss tab and drag and drop the image into the wizard. Notice in the configuration parameters that x-axis is in amps and y-axis is in volts. However, since some datasheets present voltage as the x-axis and current as the y-axis, as we have here, click on the Mirror Axis button to mirror the axis. Set the x and y-axis limits and align the axis. Next, start clicking away on the desired curve. In this case, I'm interested in a VGS value of 15 volts. Rename the imported image if desired. The manufacturer has provided conduction loss curves for third quadrant as well. I have imported and defined data points for first and third quadrant for 3 different temperatures here. The wizard also includes a fitting algorithm to calculate Foster network coefficients for the thermal impedance from heating curves. Sometimes a datasheet will provide Cower or Foster network coefficients, but when these are not given, we can use the single pulse test curve to extract values. For example, here the datasheet includes a transient thermal impedance curve. Import the graph and once again enter the limits and line up the axis. Start setting points on the curve by double-clicking on it. Remember that the wizard can fit only the single pulse curve but not the other curves. When you have selected the points with sufficient accuracy, specify the number of elements in the curve. As soon as the requirements are met, PLECS will calculate a set of Foster coefficients and display the result as an orange curve on top of the graph. If the current fit is not satisfactory, you can calculate a new one by pressing the Recalculate button. The import wizard can be used to generate custom tables as well. For example, the datasheet provides a graph for switching losses versus external gate resistance. Going back to the thermal description, we can define external gate resistance as one of the variables. Then create a new 1D lookup table for EON versus RG. Take a screenshot of the relevant graph and drag and drop it to the Import Wizard window. Then align the axis and enter the limits and click on the EON curve to create data points. Similarly, create a second 1D table for EOF versus RG and repeat the exercise. Now, I'm going to choose lookup table and formula as my computation method for my turn on and turn off losses and update the formula to incorporate the gate resistance variable. Note that you will then have a component parameter for the gate resistance available in the MOSFET block parameter window if you select this thermal description. The actual gate resistance value you specify should fall within the range of the data provided in the curve. Note that the manufacturer and part number boxes are for documentation purposes only. Then, save it to a location of your choice. Make sure to add this location to the thermal description search path and rescan the thermal library. The thermal description should now show up under Window, Thermal Library Browser. You should also be able to assign this description to a semiconductor device. For example, in this case, I should be able to add this thermal information to an ideal MOSFET. As you can see, the gate resistance field appears when we select this device, and the simulation cannot be started until a valid entry is made. This concludes the tutorial video on exploring the PLECS Thermal Import Wizard. For more videos and other information, please visit our website at www.plexim.com. Thank you for watching.